All right, Jim Bollinger again, NMH, last day of our semester. But I'm going to do a quick introductory lesson on how to get started with Trig. Give you some thoughts and some experience on how I think you might approach this from the get-go. So only two things you're going to do in trigonometry. I'm going to give you an angle, you're going to give me a ratio. I'm going to give you a ratio, you're going to give me an angle. We have to learn the language that goes with that. Let's start with right triangle trig, and let's start with the 30, 60, 90 triangle, which is going to be used consistently throughout the semester. And let's look at those ratios. First, we're going to start with a better marker. Let's see if I can find a better marker here. A 1v1, there we go. So let's see, that's about 2 marker lengths. So 2 marker lengths. 2 marker lengths. I think we're about there. That's a pretty decent looking triangle. So we got a 1, 1, 1. We are going to cut this triangle in half. Obviously, this must be 60 degrees. When I cut it in half, the left side is a half. We'll do our Pythagorean relationship up here very quickly. Make sure that you can see the video. Yeah, so 1/2 squared is a 4th. 1 squared is 1. What adds up to 1? 3/4. So this has to be the square root of 3/4, which is √3/2. Now I ask students to memorize what that is as a decimal. It's approximately 0.87. Be surprised how long it takes students to memorize that. I hope you're not one of them. So keep in mind, get a feel for mathematics, you have to have a feel for size. So 0.87, but we're going to work with the exact values, √3/2. So if I doubled the size of this, and some students and some teachers prefer this triangle. Oops, I want the 60 degree. I just drew a 30 out of habit. All right, so there, I think I kind of doubled the size of that. 60 degrees still. Doubling that is a 1. Doubling that is a √3. And doubling the hypotenuse is a 2. But the ratio of opposite to hypotenuse is still √3/2. And that's what trigonometry is about. Ratios that don't change in right triangles. So that data is stored in the calculator and you can work with it. I like to use this triangle when dealing with the tangent function. So I'll leave it there. Okay? All right. So now the next thing that's important to understand, get those, is the definitions. And so we have, for this particular triangle, we have a relationship of the opposite to hypotenuse, the opposite side to the hypotenuse of this 60 of functional notation of this 60-degree triangle, right triangle, is equal to √3/2 divided by 1. Oh, you know what? I don't think I've ever seen that in a text, opposite over hypotenuse, because that's not what we call it. We call it the sine function. So the sine of 60 degrees is √3/2, because we don't really need to divide by 1. So it's really in the unit circle, which I'm going to create in a moment. √3/2 to 1. Well, I'll keep it there for now, because you're just learning the definitions. All right. The cosine function would have been the adjacent to hypotenuse relationship of a 60-degree 30, 60, 90 triangle is 1/2 divided by 1. And the adjacent and the opposite to adjacent ratio, right? Ratios are fractions of a 60-degree 30, 60, 90 triangle is √3/2 divided by 1/2. But that's called the tangent. And that turns into √3/1, right? Because when you divide by 1/2, you multiply by the reciprocal. So √3/1. You know, eventually we're going to stop showing the division by 1, but you're learning the kinds of the words that go with these 3 major functions. And then we've got the inverse process. Instead of angle to ratio, we're going to go ratio to angle, so on and so forth. But we'll do more with that later. Okay, so now, the quicker you learn these, the better off you're going to do in this class. So tonight, memorize. YouTube video, if you want. Go to something on the internet. This is all over the place. Okay? Immerse yourself in it, because those students who don't learn the memorization aspect of that, they can't do the problems. So that's step one, and that's on you. Nobody can do that for you. You got to do it. Of course, I'm going to make you do it because we're going to do it every day. But the sooner you do it on your own, the better. Now, there's two language systems in this study. I'm going to put these triangles. I'm going to embed these triangles in a circle. All right. Oops, I got the wrong marker again. Well, you can kind of see the outline of that circle. I can see it from here. So, and then we're going to put a coordinate system, and we're going to draw remember it was a half for this is 0 and this is 1. It's a unit circle. Doesn't matter the size of the circle, the radius of 1 is the unit we're going to work with. So halfway. So first off, you go to the circumference, and then you draw a perpendicular to the x-axis. And there's our 60-degree triangle. 60-degree triangle. There's our √3/2. There's our 1/2. There's our 1. But it's embedded in a circle. Why is it embedded in a circle? Because as we draw these triangles, for instance, as I move heights up, I'm going to get this kind of repetitive graph. And there are a lot of things out there in the real world that repeat. All right, so let me just put a smaller circle here. Oh, wait a minute, that seems like a circumference. Oh, that is a circumference, and this is that's a chunk of circumference that matches up with 60 degrees. See, I did elementary school, we studied circumference as a circle. Oh, circumference is 2 pi r. Oh, and this r is 1. Oh, the circumference of this circle is 2 pi. So is the circumference of that one. If it's, I could make this a unit of 1 instead of a half. So that's, that's interesting. Huh? And once around the circle, and I'll get rid of this. I'm just going to go on the blue circle because you can definitely 1. Geez, 2 pi is the same as 360 degrees. Wow. So that must mean that pi is equivalent to 180 degrees in this study. And we call this a radian measurement. A radian. And the reason it's a radian is the word radius has already been taken. And we're not talking about that as a radius. But it certainly has connected to radian measurement. Wow. So I wonder what 60 degrees is. 60 degrees, well, that seems like it's a third. Pi over 3. Ah, isn't that interesting? Wow. So let's see what, let's do a little trig. And by doing, I'm guessing you might even be a little further along than we were 15 minutes ago, or however long this has been. So what would the sine of 2 pi over 3 be? Sine of 2 pi over 3. Well, I think pi is 180 degrees in terms of radians. It's the top half of the circle. And I'm going to break it up into 3 parts. 1, 2, 3 is over here. And I'm going to this location. And so what do I do at that location? I draw a perpendicular. And that looks familiar. I think I recognize that. That's 60 degrees reference angle. That's a 60-degree reference angle. And remember, I'm in a coordinate system now, where that's 1 and this is -1. What are the values that I have? Oh, I think that's still √3/2. And I think that, well, this is a half, but now it's -1/2. Sure looks to me like the sine is the opposite over the hypotenuse. So this is the opposite of the reference angle. And that's I'll do 2 clicks here. That's the hypotenuse. Sure looks like it's still √3/2. Oh, okay, let's see if we can play with this a little bit. I wonder what the cosine of pi over 6 is. How would we do that? The cosine of pi over 6. Let you think about it for a moment, and I'll just keep the video going because all you had to do was push pause. Hit the space bar, right? It took me, I can't tell you how long it took me somebody taught me that that's how you could freeze a video. It's embarrassing. Oh, pi, that's the top half of the circle. But I'm going to break it up into 6 parts. Did I mention that getting good answers in Trig is requiring good drawings? I guess I just did. So 6 parts. There's 1, there's 2, there's 3, there's 4, there's 5, there's 6. Now, what do? Oh, that same thing. We go from the circumference of the circle and we straight down to the x-axis. We form a nice little 90-degree triangle. I wonder what the reference angle is. Oh yeah, pi is 180 degrees divided by 6. You know, I think that's a 30-degree angle. Reference angle, yep, 30 degrees. Huh. Well, I guess I want to look at a 30-degree triangle. There's 30 degrees. Geez, you know, the smallest side of a 30, 60, 90 has been a half. I guess this is root 3 over 2, and I guess this is 1. So I guess this is root 3 over 2, this is 1/2, and this is 1. And I wanted the cosine. And you're just trying to remember right now. Cosine. Okay, well, sine is height over the hypotenuse, you know, opposite side. I guess cosine is the width over the hypotenuse, the adjacent side, right? This side is right next to this angle. It's touching it. It's touching the angle. It's embedded there. I guess that's root 3 over 2. I think we can keep trying these here. Let's see if we can try these. Let's try another one. How about we do the sine? Let's do the sine function. How about we do the sine of 17 pi over 6? The sine of 17 pi over 6. Hit the space bar. I won't. Oh, circle. Lost a little bit on the shoulder on that down there. All right, top half of the circle, 6 parts again. Well, I guess each part's 30 degrees. 1, 2, 3 chunks of 30 get me to 90. 4. Oh, that's a bad one. I don't like it. 4, it's a little better. 5, 6. Oh, I guess there's 6 there. Then there must be 7, 8, 9, 10, 11, 12. There's got to be 12 of them. Oh, 12 chunks of 6. Yeah, 12 times 30 degrees. Yeah, 360 once around. I got to get to 17. Seems like I got to go another 5. 1, 2, 3, 4, 5. There I am. What do you do when you get to the circumference circle? Oh, yeah, perpendicular. 30-degree reference angle. What are the values? The values are negative root 3 over 2 is the width. Positive 1/2 is the height. Hypotenuse is still 1. Is always positive 1. That never changes. Sines, it's 1 no matter where we draw the triangles. Sine, let me think again. Oh, opposite over hypotenuse. Opposite over, guess it's a half. Guess it's a half. Couple more, and then we can turn our attention to something else and come back to this in 20 minutes when you've forgotten everything I said. That's how you get long-term memory. Do something, get away from it, come back to it. All right, but let's do one more. How about we do the cosine of negative 19 pi over 3. The cosine of negative 19 pi over 3. Negative 19 pi over 3. Oh, I'm sorry. You can hit the pause. I don't have to pause. Oh, yeah. Well, you may have guessed correctly that we're now going in the other direction. So we got 3 down here. There's a chunk of 1, a chunk of 2, a chunk of 3. I guess if there are 3 in the bottom half, if there are 3 in the top half, that means this is negative 6 pi over 3 over here. And we're going in this direction. So I guess negative 12 pi over 3 over here gets me back. I guess negative 18 pi over 3 gets me here. Those are called coterminal angles. And so I guess 19 is right here. How do I draw the triangle? Oh, this time I'm going up to the x-axis to form that. Now, what's the smallest side in that triangle? appears to be this. I wonder what that distance is. Because we're moving in the positive, and that's 1, that's negative 1. You know, if you said a half, you would be right. If you put this hypotenuse as 1, you would be right. And most people, when they're first learning, will write √3/2 and forget to put the negative sign. But we're below the edge. Remember, this is in a coordinate system, so it's negative √3/2. What's cosine? Cosine's not opposite over hypotenuse. It's adjacent over hypotenuse. So in this case, 1/2. Now, I don't know how long this video has been recording, but I'm guessing not much more than 15, 20 minutes. And maybe you're even up to speed a little bit. You know, usually in the physical classroom, right about now, I start to see 3 or 4 people just begin to do this. So I'm going to also be talking about the 45-45 triangle. I better do it now so I don't have to do a separate video for that. Let's see if I have a marker here that does some justice to the cause. There, that's not too bad. So if this is x and this is x and this is 1, well, you know, if that's 1, then the square area is 1. I'm going to attack this differently than I have before. And these are the same lengths, so I wonder what that has to be. If these two squares add up to 1 and they're the same amount, I guess they have to be a half. I guess they have to be a half, which means that this length is the square root of a half. All right, so we're going to look at the square root of a half. What times what gets you a half? What decimal? Well, 0.7 squared, 0.49. It's got to be a little bit bigger than 0.7. Okay, but let's get it exactly. So square root of a half, positive distance, so I didn't have to say plus, minus, or anything. Well, I think that's the same thing as the square root of 1 over the square root of 2. I think that's the same thing as 1 over √2. I think we rationalize. √2, I guess it's equal to the square root of 2 over 2. Well, square root of 2 is approximately 1.41. I want you to memorize that. And if you divide that by 2, this is approximately 0.705, I think, something, In my class, I say, hey, let's call this 0.71. 0.71. Okay? So we could start to do, you know, remember that opposite side. So here's your triangle, 45-degree triangle. And we'll do one more problem with it. So there's angle X. Oh, no, we know it's 45 degrees. We know we got 90. So this is √2 over 2 in the unit circle. √2 over 2, and this is 1. So why don't 45 degrees? I think that's 180 degrees divided by 4. So I guess 45 degrees could be a chunk of pi over 4. Degree measurement, radian. Okay? Radian, yep. Let me talk about radian one more time. Here's a circle. There's the radius. So I got my lanyard. There's a 1 unit length. What I do is I wrap it around the circle, and that's 1 radian, which is approximately 57.3 degrees. We'll talk about how I got that later. Okay, so this is the same distance as that radius, but we got to call it a different name because it's not connected to the center of the circle, to the circumference. This is what is referred to as a radian measurement. Okay, last problem we'll do 45 degrees. So let me see if I can figure out what the tangent of 19 pi over 4 is. 19 pi over 4. Oh yeah, I don't have to pause. I keep thinking physical classroom here. Hit the space bar. All right, 19 pi over 4. We got a circle, terrible looking circle, shoulder injuries. Pi over 4. Oh, I guess I'm breaking the top half of the circle 180 degrees up into 4 parts, which means there's 4 parts below, which means that 8 pi over 4 is once around. Losing the marker. I'll try to find something real quick. Come on, green. Do some justice. Well, I got a red one. Let's see how it goes. So 19 pi over, so 16 pi, right? That's a good one. 16 pi over 4 is coterminal. We got to get to 19. So if this is 8, 16, 17, 18, 19, we draw a perpendicular. We know that this height is √2 over 2. You got to be careful with this one. Got to be careful with that one. It's negative √2 over 2. And that's 1. So what is the tangent of 19 pi over 4? It's opposite over adjacent. I like to say height over width. That divided by that, -1. Okay, so you've had an introduction to trig. In my class, we do it again tomorrow. We do it again the next day. It's on every test the whole semester. When you start getting the hang of it, there won't be as many questions as you'll see tomorrow, but we're diving into it. All right, so there you have it. I'll post this, and hopefully you can look at it over the summer.